So not solutions, not equations.
2 sets of numbers.
If we are factoring, what were we finding?
The 2.
GCF. Greatest common factor.
No. I mean, we did do some of that, but what are this 2 and 5 called?
Prime numbers.
Well, they are prime numbers. You're making this difficult. What are these 2 numbers called?
4 and 5.
Multiples or?
Variable.
It starts with an F.
Factors.
Factors. We're finding factors. We're factoring. Right? So we're looking for numbers that multiply together to give us the original problem. We're undoing the multiplication process, right? We're going in reverse. And we said there are multiple ways that we can factor. We've done prime factoring, which you just told me was this one. I heard some of you saying GCF. We were factoring out GCFs. How many terms can a problem have for us to factor out a GCF?
2.
Could have 2,
Or 3.
or 3,
4.
or 4,
20.
or 20, or a million.
2.
Because we can factor a GCF out of any amount of terms as long as they have a GCF in common. Okay, and then we moved on to factoring by grouping. And we said factoring by grouping would work if we had what? How many terms?
4.
4 terms. Now, realistically, factoring by grouping can work with anything that has an even number of terms because we could split it in half. We are focusing on 4 terms here. When you get to second year algebra, you'll look at some factoring when there's more terms. You know, if there were 6 terms, we could split it into 3 and 3. Okay. We're going to stick to 4 terms, so we're still in this world of 4 terms today. But now we want to add some pieces that we haven't talked about yet. What are some things that we can do with factoring by grouping that we didn't get to on Friday? Friday we were saying, let's make sure we understand the process. Let's make sure we understand the basic concepts, right? Let's make sure that we could go through the steps, we could get it into its 2, what are these 2 things called other than factors at the end when we get these things? Binomials, right? 2 terms, so we had 2 binomial factors. So now we want to say what happens if that looks a little bit different towards, well, not even towards the end, towards anywhere in the problem. What happens if that looks a little bit different, and how can we then do something with it? So, I think I would have this page number memorized at this point, but I still don't. Oh, I wasn't even close. I tried. Let's say we want to factor something that now says 4x to the 4th minus 8x to the 3rd plus 12x squared minus 24x. When we were looking at these on Friday, what did we say our first step would be?
GCF.
Is there a GCF of all the terms?
Yes.
Man, I am a hot mess today.
You gotta split it, right?
So before we split it,
Oh, you got
you said there's a GCF of 4, but on Friday the answer to that question was always no, right? There wasn't a GCF of everything, but today that answer might be yes. So do all 4 of those terms have a GCF?
Yes.
Yes, it's 4. 4, what else? X, because they also all have the variable. So now we can factor out a GCF of
What?
all of them.
X.
Okay, so 4 divided by 4 is
1x.
1, and right? 4 minus 1 is 3. 8 divided by 4 is 2. X squared. 12 divided by 4 is 3x. 24 divided by 4 is 6, and then the x's cancel out.
Now you can square.
And so where do I write that GCF?
You would split parentheses and then 4x.
Okay, so now I have this. Right? That is equivalent to my original problem. What does the word equivalent mean?
Same now.
Right? It represents the same value. This is sort of like prime factoring 20 and splitting it into 4 and 5. Okay, when I split 20 into 4 and 5, do I stop there? No, why not?
Because you can still.
Because I can still do something with the 4. So I factored out a GCF, but, oh, this color is so ugly. I need to choose a better color. I don't know, I gotta figure that out. I can still factor those 4 terms. I know it's hideous, just ignore the ugly color. So now if I want to factor these 4 terms, what do I do to factor those 4 terms? You just said it a second ago, Billy. Split it in half?
Yeah.
Okay, so I'm ignoring this altogether. I'm not paying attention to this GCF. Because if I go to prime factor this 4 further, does the 5 have anything to do with it? No. The only place I'm looking is right here. And so I'm focusing on this piece, and I'm splitting it in half. Okay, so if I focus on these first 2, now again, some of you might say, okay, I've got way too much stuff going on my sheet of paper now. I've got this GCF sitting out in front. I need to rewrite this so I can just focus on what I need to focus on. Some of you might say, well, I don't need to do that. I'll just cover it up with my hands and pretend it's not there. That's a personal preference. That's up to you. Okay, so x to the 3rd minus 2x squared. What's our GCF here?
Oh,
X is the wait.
2.
how do you do that?
1.
Okay, so there's a 1 here. So what goes into 1 that also goes into 2?
1.
1. Do they both have the variable?
Yes.
Yes. Smaller exponent.
X squared.
So we'll pull out an x squared. Does that remind us we're okay? Okay. So 3 minus 2 just leaves me with an x.
Minus 2.
And students start going, oh my gosh, Mrs. McKinney, this problem is really long and there's a lot of stuff going on. Yeah, we haven't got to the worst of it yet. They get longer. Not so much today, but they do by the end of this unit. I know, it's not hard though, it's just a lot of stuff, right? What goes into 3 that also goes into 6?
3.
You with us, Sam?
3.
Morning, sunshine. Do they both have the variable? They both have the variable?
That's 1.
Oh.
Oh,
Morning.
I said 3 too. I said
So let's pull this 3 out. 3 divided by 3 is 1. 6 divided by 3 is 2. So that takes us here. Do our binomials match?
Yes.
Yep. Do they need to match?
Yes.
Yep. How am I then going to write my final answer? Sam, what do you say?
X squared minus 3 plus 3.
Because this is a positive. Yep. And then what's our second binomial going to be?
X minus 2.
What are you thinking?
I'm gonna look if you say you got X squared plus 3.
So I'm taking my 2 GCFs
Yeah. Oh.
and I'm putting them side by side. It's a positive 3, so that's where my addition sign came from.
That's
Now we don't want to just circle this and say that this is our final answer. Just like over here, if I were prime factor 4 into 2 times 2, Would my final answer just be 2 times 2? No. What else would I have to count?
The 5?
Right? I'd have to count what I factored out earlier. So what had we factored out earlier? And so this is still part of my final answer. Yeah, it's a lot. And there's only more to come as we go throughout the weeks. But here's what I want you to see, and this is the piece that students I think sometimes struggle with. I could stand up here and say, okay, yeah, just do this because Mrs. McKinney said so, but we really are just doing a factor tree. The numbers are just bigger. I split this whole original problem into a 4x and an x to the third minus 2x squared plus 3x minus 6. And then I split these 4 terms into these 2. So my final answer is everything that doesn't have a branch coming off of it. This one, and this one. Or just prime factoring with much more complex numbers, right? But we are doing the same thing that we've always known how to do. What do we think? I'm seeing bug eyes.
You just made it a little bit more confusing for me, but I know how to do it, so.
What made it more confusing for you?
That you said we're doing it like the factor tree and you made all those lines, that just made sense.
Okay, you're correct that I understand that my students sometimes go, that's more confusing, but it's important. It's going to be really important in the long run, so let me reiterate that a little bit and see if I can word it differently. I'm going to pick something that's maybe easier. No. Duh, I'm going backwards. Let's say I wanted to factor this. Okay. What might you do first, Kaden?
So it's 6x.
Okay, so you might factor out a 6x. I'm not going to factor out a 6x. I'm going to be like, ooh, I didn't see that, so I'm just going to factor out a 6. Okay, and so I'm going to factor this into 6 times x squared minus 2x. Okay, I missed the GCF. I factored it. I didn't necessarily factor it wrong, right? I did correct math over there. So if I just say, oh, I just want to factor, I mean, this is correct factoring. But we eventually want to get to the point that we can prime factor a polynomial. We don't just want to factor something out, we want to factor everything that we can factor out. Which is why it's going to be important that we then recognize, okay, but I could have gone further with this. Right? I could have factored this again and pulled out an x. And so I factored out an x, I factored out a 6, and I was left with an x minus 2. Right? All of those pieces are going to be important because if we just decide, oh, all I have to do is factor, well, what's wrong with doing that? Well, it's going to be a big problem because then we're not going to be able to do anything with quadratics later in the trimester. Okay? You don't have to be perfect at this yet. This I want you to just have an introduction of and say, okay, yeah, I see that. It's a lot, but I see it. Yes, Sam?
I think the hardest part is there's just a lot of numbers to keep track of.
Absolutely. Okay, so I don't want to throw anyone under the bus. I don't know you all well enough. But some of your handwriting is terrible. And when you write, it is disorganized all over the place. You know how, like, whether you had myself or Mr. O'Neill or Mr. Bushy or Mrs. Pillsbury were like, show your work, and like, we want to be able to follow your work. We're not completely crazy people. Problems start to get longer, and if you can't follow your work, you'll get lost in your own work. Have any of you ever wrote something down wrong because you couldn't read your own writing? Right? It's only going to get that much worse with this much stuff going on your paper. So we will be practicing that a lot. How do we sort of keep it organized? How do we follow where we're going? How do we do all those steps? Okay, we'll get one more problem with factoring by grouping because there's one more piece of grouping that we still need to look at today. And then we'll be done with notes and we'll just be doing some practice, making sure we're okay with some different things that happen, some different hiccups that come up along the way. How about eight? Oh, I don't need to write that thick. Let's try again. 8m to the third plus 12m squared minus 2m minus 3. How many terms does this have? 4. So what are we going to do first?
Now find your number.
Is there a GCF of all of them?
Yes.
No.
No. So now step 2, what can we do?
You can split it.
Split in half. Okay, no problem. What next? GCF of each side. So what goes into 8? That will also go into 12. 4 m squared, right? Because they both have the variable in the smaller exponent. 8 divided by 4 is 2. 3 minus 2 is 1. 12 divided by 4 is 3. Any m's left? Nope, those cancel out. Okay, so can't go any further. Nothing I can divide here, so we did get the GCF. Right-hand side, what's our GCF?
Oh, M. No.
Do they both have an M?
Yeah, no.
Nope, so we can't plot an M.
Is it -1?
I don't know, you tell me. Is it 1? Is it -1?
It's negative.
Why are we thinking -1?
Just
You put two negatives.
Okay, so it's actually going to be a little bit more complicated than that because a GCF means what?
Greatest common factor.
Greatest common factor. Greatest. What does the word greatest mean? Bigger. Is -1 a bigger number?
No.
No. Oh dear.
1.
Okay, so should we go with 1 then? Oh dear. Okay, well, so don't write yet because you'll be grumpy, especially if you're writing in pen. So just watch for a moment. If I pick 1 and I pull out 1, oh, I heard some O's. What's our dilemma?
That's not right.
Why is it not right?
It doesn't match.
Because my binomials don't match. Okay, well then how are we going to make them match? Okay, well if we do -1, but then my students are like, but wait a minute, Mrs. McKinney, if I do -1, but then greatest isn't larger. So we're kind of bending the rules kind of a little bit here. Okay, what is a negative divided by a negative? A positive, and a negative divided by a negative is a... So we really are kind of bending the rules a little bit. And the rule says, if, right here, if the leading number in this second half, only in the second half, if the leading number is negative, then pull out a negative, factor out a negative. So if you look at the two numbers and you're like, okay, my GCF is 7, if the leading one is negative, make it a -7. For those of you who haven't had me before, whenever I write on the whiteboard over here, that means you don't need to write it down on your notes. I just want to make sure you're visually understanding my words. So if I had something that said this, what goes into 7 that also goes into 14? 7, but the leading one is negative, so what should I do with my GCF? Make it negative. That's what that statement says.
But if your second number is negative, but then
Right, if it's just the subtraction in between, that's not the issue. Now, the reason why we're doing it isn't necessarily GCF, because that made the number smaller, but because we need matching factors here, right? The key is that these need to match, otherwise nothing else works. Mathematically, when we change this to a negative, we call it an opposite factor. I don't need you to go home and memorize that word. What does the word opposite mean?
Reverse it.
Right, if I say 4, what's the opposite of 4? Negative 4. You change the sign. So that's literally what we did, was pull out a negative and change the sign. And so now we have something that matches, and now I can say 4m squared minus 1 times 2m plus 3. No? Are you okay on that? Oh, I thought you were asking, confused on something.